Hi there, my name is Dr. Minkevich, but you can call me Dr. M, and I'm going to be walking you through Lab 3, Motions in the Sky. Labs 3 and Lab 4 will use the free online Stellarium planetarium software, which you will need to download before you begin from stellarium.org. So you're going to click on stellarium.org, and you're going to want to pick your platform. Most of you presumably won't be using Linux. Most of you will probably be using Mac or Windows. I think 64-bit is appropriate. So for Mac OS X, if you're not using OS X 10.10, if you're using something earlier, you'll want to look around at some earlier versions of Stellarium. But otherwise, most of the stuff on this page is not helpful to you. The only thing that's on this page that should really be useful is the user's guide. I'm going to talk you through most of the basic features of Stellarium now, but if you like what you see and you want to play with it more, the user's guide is potentially quite powerful, and might as well have a look at it. It's full of all sorts of detailed stuff. So once you boot up Stellarium, it's a little wonky in a Mac. It opens up a window, and then I have to go find my menu again, shrink it, so that I can get back to my lab. Once you have Stellarium installed, you'll want to start Lab 3, but Lab 3 isn't inside Stellarium. Lab 3 is actually a Blackboard quiz, so click on Course Content, click on Week 2, click on Lab 3 Motions in the Sky, which you probably already did this to download the Stellarium, and then click on the Blackboard quiz, and click Begin to start answering the questions. Now you can save your answers to your questions as you go, but remember that you only get to submit this one time. So here are the questions, and the first set of questions, which I think are questions 1 through 9, you actually don't need Stellarium for the first part of the lab. For the first part of the lab, you're just going to answer questions about this picture of the celestial sphere. There are a number of astronomical terms used in this section which are not actually explained in great detail. I'm going to explain a few of them now, but you should always feel free whenever you encounter one of these unfamiliar terms to just go ahead and either look it up in your AST 111 textbook, or Google it, or use Wikipedia to look it up. So the first unfamiliar term is probably the celestial sphere itself. The celestial sphere is a model of the sky. It's this big half circle, half dome right here. And it's often pictured with a coordinate grid drawn on it, and it allows astronomers to locate objects in the sky. This particular version is an observer-based model, which means that it shows you as the observer standing on the Earth, somewhere in the northern hemisphere. And from your point of view, it looks like all of the stars and the sun and the moon and planets are equally far away, and they are slowly rotating from east to west around you as the day and night progress. This is not what's actually happening. In fact, stars and planets are all actually at very different distances from us. And the sky itself does not move. It's the Earth that's rotating around on its axis that's actually moving. And that's what causes the sky to appear to spin around us. But we're going to start with this observer-based model, which is sort of wrong, geocentric, because this is how our ancestors started, with the assumption that the Earth didn't move, the sky did. And it's useful. It's useful for getting oriented with the night sky. So some of the other things in this picture, which you may or may not be familiar with, are the horizon. The horizon, I think everyone's familiar with standing on the ground. It's the boundary between the sky and the ground. But here it's drawn as an infinite plane that extends out from 90 degrees from the zenith all around you. The zenith is the point directly above you. The nadir, Nadir, nadir is the point directly below you. Point 1 over here is in the east. Point 3 over here is in the west. The observer here is facing south. The North Pole is behind him. The observer is somewhere in the mid-latitudes of the Northern Hemisphere, and this lab is Northern Hemisphere biased. Sorry, Southern Hemisphere people. You know it's Northern Hemisphere biased because everything is rotating from the point of view of a person standing on the ground. Everything appears to rotate around the North Star in a counterclockwise fashion. If the observer were to turn around and look at the North Star, which is where the North Pole points on the celestial sphere, he would see the star B rotating around from east up to the zenith, over to the west, and then down here in a counterclockwise fashion. That's actually kind of the definition of north, that if you look at north, everything seems to move counterclockwise in our night sky and even in our day sky. And if you look at the solar system, if you were to fly above the Earth, way above us, and look down at the solar system, you would see the Earth is spinning counterclockwise on its axis if you're looking down on the North Pole. And the planets are going counterclockwise around the sun. And most everything in the solar system appears to be moving counterclockwise. The opposite would be true if we were in the southern hemisphere. Everything would appear to move clockwise in the southern hemisphere. But we're going to stick with the northern hemisphere for now. Star A rises in the east, hits its highest point at point 2, and sets in the west at point 3, back on the horizon. And this other star, Star B, also goes east to its highest point and then down to the west. And then it doesn't actually dip below the horizon. This is a feature called circumpolar stars. Circumpolar stars are stars which are so far to the north that for a person standing in the north, they never reach the ground. They never appear to set. They're always visible. If the sun were to go out at night or during the day and you could actually see stars, you would see that star B is still visible at all times, all 24 hours. And what else do I need to tell you? The meridian is this line that runs from north to south through the zenith. And stars reach their highest point or transit at point 2 as they cross that meridian. And that meridian is defined for you wherever you are standing on the Earth. And I think that's all you need to answer those questions. So from here, we'll move on to the Stellarium questions. So we'll open up Stellarium, and the lab suggests that we play with it a little to get used to it. And this is actually good advice. So we'll open up Stellarium, and 2 menus are of importance. First of all, this menu over to the left. It's not visible most of the time. I've had a few students in the discussion boards already ask me where the question mark is. The question mark, you have to go over to the left side, hover, and this menu will appear. And there's your help window. And the help window gives you a lot of the keystrokes, which are shortcuts. I actually like using the menu. Most of these things you can do via the menu anyway. And I think starting out, that's a little more intuitive. Sky and viewing options window, date, time window, location window. We know we're going to need to be in Phoenix, so we'll just do that now. And as soon as I click on Phoenix, you'll see the latitude and longitude change over here. Click on Phoenix. But the arrow for me, for whatever reason, the arrow is still pointing down here in Brazil instead of at Phoenix. I don't know if that's just a bug with my particular thing. So now we're set to Phoenix for our location. But before I move forward in time, I'd like to show you some of the help options. Some of the most important commands are these single letter commands. Those are the most fun to work with, and the most important, really. But there's several more that you can look up in the user guide, and several more that are described in the lab itself. This menu down here has important things like the cardinal points. So like I know I'm facing south right now because there's a big red S on the horizon, but I can turn that off. I can also turn it off and on by pressing Q. So if you're ever disoriented and you don't know where you're looking, you can press Q. And G, or the trees down here, the trees make the horizon come and go. So the Earth basically vanishes and you're floating in space. You can grab the sky and drag it at any time. Although if you get near the zenith or the nadir, it'll start doing this flipping around thing, which is kind of annoying. And it's actually important to have the cardinal points up because I get lost when that happens to me too many times. If you press G, the horizon comes back. Those are the southern hemisphere constellations that we were looking at because we're now standing in the north. These blue things, these blue starburst things, these are they're automatically loaded in. They're meteor showers. These are the origin points of meteor showers. I think they're cool. I also think they're extremely unnecessary for the lab, so you can turn them off in the lower menu by pressing this meteor shower button, and those will go away. You'll probably want planets on for most of the lab, but there's a better menu over here in Sky and Viewing option. SSO is Solar System Objects, and we're going to need to mess with this in order to get some of the answers in the later questions. Deep Sky Objects, which will show you things like galaxies and clusters of stars and nebulae of different sorts. And they have some pretty weird names, it turns out. I didn't know there was let's see if we can click on those. Lost Jewel of Orion, Salt and Pepper. At one point I saw the Electric Guitar Cluster, which I thought was one I'd never heard of. So these are some things you can play with. The most important commands after the question mark, the most important commands in Stellarium are the time button. Down here there's a little fast forward, play, and backwards, rewind. And you can click on these. And this makes time go faster until it's going so fast that you actually start to see the stars move quite quickly if you want. And then the sun comes up. When the sun comes up, I actually have the option of I can turn the atmosphere off, and now you're in space. So you can see the stars that are hiding behind the sun and the planets that are hiding behind the sun if you turn the atmosphere off. You can also make time go backwards, which is exciting. This button will first it will slow down time, and then it makes it go backwards. If at any time you decide you want time to just go back to normal, just click on this play button and it goes back to 1 second equals 1 second. It's also the pause button if you click it twice. Both of those are important functions. You can do all of these things using the J, K, and L buttons. So I will remove my cursor from the menu, and I can do the same thing by just pressing L. Time goes very fast. K pauses it, and J makes it go backwards. Oops, too far. Okay, so the other important thing that you'll want to keep track of, I'm going to turn the atmosphere off for a second, is the zoom. Especially these things over here are oculars, and these are basically telescope simulators. So you can click on an object and then zoom in on it with the ocular, and you can see the field of view. It can be quite neat, and it's worth playing with. But often when you zoom out, you don't zoom out all the way. So zooming in and out. I'm currently able to do it by pressing either the page up and page down button. That'll do it. I also have one of those little rolly balls on my mouse that does it. I think there's something equivalent on the trackpad, but I haven't been able to make it work. So this is how you zoom in and out. Page up, page down, roller balls up and down. There might be a trackpad equivalent. And that's important because some of the answers depend on how much of the sky you're looking at. A few other features, constellation, labels, lines, These are called stick figures, and they're how we normally draw the constellations. Labels, so you can see which constellations they are. We also have the ability to turn on fancy art. Oh, that's the wrong one. There's a button that will turn on the pretty diagrams of the Greek myths that go with each one of these constellations. And the grid lines. So there are two grids. There's, I said before that there are coordinate systems that are attached to the sky. This is the equatorial system, and it's attached to the sky. So it's centered on the North Pole. This is the North Star right next to it. And this set of grids moves with the sky. So if I make time go forward faster, as you can see, the grid lines move with the sky. And those are the coordinates on the sky. They're called right ascension and declination, and maybe we'll get to them in a different lab. The other grid system is the azimuthal or horizon system, and that's anchored to you on the ground. It's centered on the horizon and the zenith. And when I make time go forward quickly, you'll notice that the equatorial system, the coordinates are rotating along with the stars, but the azimuthal system, those coordinates stay the same because they're anchored to you. And of course, all of that was sort of a misnomer. Of course, the stars are the thing that don't move. You're the thing that's rotating, but that's not what it looks like from your perspective, and it's not what it looks like in this planetarium. And I'm going forward so fast that the sun is going down. All right. So when you play with the oculars, I'm going to turn the grids off for a second. Sometimes you'll get stuck. I've had things happen where I'm playing with these and I can't get, let's see, it's over here in Andromeda. I can't, after I've done the ocular thing and I've played with the Telrad and the zooms and the various things, I can't get back to the original zoom that I was at. So I have to use the zoom button. And then I was having difficulty getting the grid lines to come on afterwards. They're working now. I think sometimes Stellarium gets a little screwed up, and you're going to need to reboot it. If a button isn't working when you think it should, sometimes it's in your best interest to simply hit the stop button over here and restart Stellarium. I think sometimes it does get a little buggy. That's just about everything I need to tell you. Oh, when you click on these stars, sometimes as you're clicking around the sky, all this information will pop up, and it's super useful for the lab, but then you can't make it go away. So you have to click on the name of the star up in the upper left, and of course, sometimes when you do that, you accidentally click on some other star. So, click around until you're not clicking on a star, and that'll make it go away. And I think those are all the features that'll trip you up right away. So let's go on and switch the time and date and to, it was March. Okay, let's do it this way. March 15th, right at sunset. Did I turn the atmosphere off? I did. And that was at 6:36 p.m. So as you can see, we're right at sunset. It's got a nice Stellarium style sunset. And they want you to face east and turn on some constellations, and then answer some questions about which constellations you see in different parts of the sky at this time of day. For this section, again, we're going to need to use Stellarium to answer the questions. And this section actually talks a bit about altitude and azimuth, but it's mostly concerned with finding planets in the sky. And the first question asks you about finding a planet that is below the horizon in the west. at sunset again on March 15th. So again, we're going to need to go back to Stellarium and make sure that we're still on March 15th. And we're going to need to make sure, we may have drifted while we were answering other questions. We're going to need to set it back to sunset, which was 8:36. And then it asks us what star is below the horizon at sunset. And here we have a little bit of a problem. What planet, rather, is below the horizon. Here we have a little bit of a problem because the atmosphere is on, so we have to turn that off. Many planets will appear after we turn the atmosphere off. So we see a whole bunch of planets above the horizon. To see below the horizon, we can either click the ground, the little trees icon, or we can press G to remove the ground. And the little W for the cardinal point, again, Q will make the cardinal points appear and disappear, marks the western point on the horizon. The sun has just set, and I don't see any planets below the horizon. So I know how to fix this. We want to go to Sky and Viewing Objects. And we want to click on SSO for Solar System Objects. And we're going to click on Show Planet Markers. That will help us find the faint planets. And then we're going to see labels and markers here. We're going to move this bar all the way to the right. You actually have to do this for the the last few exercises as well in the lab. But I find that I needed to do it to answer these questions as well. And voila, here we have a couple of missing planets that were below the horizon. These objects were too faint for Stellarium to initially mark them, and when I moved that slider bar that was basically telling Stellarium I want to see the really faint things as well. And Neptune, which is one of the major 8 planets, is actually very faint in the sky. And so Neptune has appeared when we move the slider bar. So has Juno, which is an asteroid in the asteroid belt. But it's a planet, so we're going to pick the planet. The next couple of questions ask us to work with Uranus, which is easy enough to find. You can play with the constellation, scrolling, the constellation art or stick figures in order to find which constellation Uranus is in. And the most efficient thing to do to answer these questions is simply to click on Uranus, and it asks you to watch the altitude of Uranus, and you can actually just read that right off the chart here in the azimuth altitude, and altitude is the second number here, and they want you to answer the question for 8 p.m. so you're going to need to switch the time over here to 2000 hours and watch how the alt changes and then record the altitude. Uranus is in the west at this point, which means that as time goes forward, it's going to set, and so it's going to move down, and so you'll see its azimuth get smaller. This next section starts out with a little bit about zooming in and out in Stellarium, but you actually don't need Stellarium to answer the next several questions. The next several questions are focused on these pictures. Again, we're talking about the celestial sphere and we're using these models. You don't use figure 6 so much except for the last one. It's mostly figures 4 and 5. What do you need to know? What you need to know is that each star, we have star A. Star A is this one over here, which follows this path, this wider path, this circular path, rises in the east, sets in the west, and it actually goes and hangs out in the south for most of its path. Star B is what's called circumpolar. It never rises, never sets. It's above the horizon all night and actually all day. And it goes into the east and it goes straight overhead and then it goes into the west. But when it dips down, almost to the northernmost horizon point, it never sets. It just coasts along the bottom and comes back up. Depending on how far north you are in latitude, more or less stars will be circumpolar. But all of the stars, regardless of whether they're circumpolar or not, take 24 hours to complete their circle. So all of the stars will be in exactly the same position 24 hours later, minus 4 minutes, but almost 24 hours later. And so it takes 6 hours to complete each one of these quarter segments, which is important for one of the questions. So if star B starts out at the bottom at 6 p.m., you know that it'll have traveled all the way to the top, at 6 a.m. And it takes 6 hours to get to each one of these quarter segments. Likewise with star A, even though it has farther to travel, it'll complete the whole circuit in just under 24 hours. And it takes about 6 hours to complete each quarter segment. Now, some stars spend more time above the horizon than others. The star that rises in the exact east and sets in the exact west, like star A, spends exactly 12 hours above the horizon. But stars like star B spend all of their time, all 24 hours above the horizon. Stars which rise north of the exact east point, and there are stars like that, they will spend more than 12 hours, but less than 24. Stars that rise further south will spend less and less time above the horizon until you reach this point over here. Stars that are below this point of the celestial sphere, those are the true southern stars, and include the circumpolar southern stars for people in the southern hemisphere. These stars are completely invisible to a person standing in the northern hemisphere. And this circle here, 1 to 2 to 3 to 4, is replicated in figure 4. This is the view of the guy standing on the earth looking north. It goes 1 to 2 to 3 to 4. And again, for this part of the lab, this last section, we're going to be looking at sidereal motion of the stars, or the rotation of the stars around the celestial sphere, which of course is an illusion. The stars aren't moving. It's actually the Earth rotating and carrying us around. So again, we're going to need to use Stellarium, and we're going to be messing around a little bit with the rate of time. So I'm going to use the J, K, and L button, but you can also use the little fast forward, reverse, and pause play button. So I'm viewing the west right now, and I'm going to speed up time. And there's a question about which direction the stars move. That's a little too fast, making me a little sick. There's a question about which direction the stars move with respect to the western cardinal point. Notice that they're not moving straight up and down. They don't go straight into the west. They would if you were on the equator, but we're not. And there's also a question about what does it look like when they're rising in the east. Again, they're not coming straight up out of the east. They're moving at an angle. And just for fun, we can go and look in the north. There's the other direction. And in the north, we actually see Polaris, the North Star, and we can see how the stars circle around it. And some of these stars, they never set. They just graze the horizon and come back up. And Polaris basically doesn't move at all. I'm going to pause the lab for a second. Then there's a question about the dwarf planet that is visible at sunset looking towards the east. So if you're going to answer this question, you have to make sure, once again, that the time and date are set back to March 15th, because after you've been playing with time, moving it backwards and forwards, you will probably not be on March 15th anymore, and you need to make sure that you're at sunset again. So go back to 1836 or so. And you're going to be looking at another faint solar system object. So once again, you want to use the solar system menu, SSO. You want to make sure that planet markers are on, and you want to make sure that your label and markers scroll bar is all the way to the west. And this will help you find the object in the east, which horizon. So it's sunset, we're looking in the east, just the other way. And we're looking for a dwarf planet in the east. 218 Bianca is not the dwarf planet you're looking for. It's not a dwarf planet at all. It's just a regular asteroid. You may have to scroll out a little bit or drag the screen up to find the actual dwarf planet in question. And you'll want to click on it in order to get its azimuth and altitude. And you can press R to get the constellation R to find out what constellation it's in. Although, actually, that may be listed over here, IAU constellation. It's in Cancer right now. And then you'll want to hit L a couple of times in order to make it start going forward and see what changes. Does the azimuth and altitude change? Yes, they do. Does the constellation change? And that'll give you the answer to that question. And I think that pretty much closes out this lab. So I think I won't see you again until the Small Worlds lab in a few weeks.